Okay, first thing we're just going to call this permutations with grouping. Because we've already talked about restrictions, as in if there's a restriction on a decision, we deal with that decision first. So I don't want you to mix up these two different strategies. This is going to be permutations with groupings. So in general, sometimes objects can be grouped together within a permutation. For example, let's see, what would there be something? You have a whole bunch of video games at home. What's your console? Okay, you got a PS4? So you've got your PS4 games, or do you have more than one console? You have PS4 and an Xbox, or you just have the one console? Okay, so you have your PS4, and then you have different genres of games. You've got your sports games, you've got your, I don't know, shoot 'em games, and then shooting games, and then you've got your other games. And so you want to put your nice PS4 games all up on a shelf, but you want to get them into categories. So that would be a grouping question. And whenever we do that, we organize our groups first, and then you organize within each group. I don't have a PS4, so I had to make up a question that was, related more towards me. Oh, I want to arrange my math books on a shelf. And I have 4 different calculus books, 5 different algebra books, and 4 different geometry books. And if I want to keep the subject areas together, how many ways could I do this? So now we have 4 decisions to make, basically. So we're going to do 4 spaces. Our first decision is how we're going to do our groups. So we're going to write groups under here. We have 3 groups. 3 groups can be arranged in 3 factorial ways. Because I could have calculus, algebra, then geometry, or algebra, calculus, geometry, so on and so on. There'd be 6 different ways that I could just put the groups up. Then, once I've decided on my groups, I've got to arrange my books in each of the groups. So I've got calculus, algebra, and geometry. I have 4 calculus books. They could be arranged in 4 factorial ways. 5 algebra books could be arranged in 5 factorial ways, and 4 geometry books could be arranged in 4 factorial ways. Multiply all those together, and we would get the total amount that we could arrange. So this is a grouping question. In grouping questions, you do the groups first, and then each individual group separately. 5 people, Amy, Bill, Jill, Lee, and Tom, are at a park bench. How many ways can they be seated? And of course, it's springtime. Jill and Bill wish to sit together. So this is a grouping question because you've got Jill and Bill as one group, and then Amy, Lee, and Tom. And so sometimes people think of this as 4 people because now there's Amy, Lee, Tom, and Jill and Bill are never seen separated, so they're just now known as the Jill Bill. And you count it as 4 people, or you can think of them as 4 groups. Here, I'll just do either 4 people or 4 groups could be arranged in 4 factorial ways. But then we have to do the arrangements in the individual groups. Now, there's the Jill Bill group, which could be Jill Bill or Bill Jill. 2 factorial ways. And you could do the other groups with 1 factorial if you wanted, or you could leave this part out. It wouldn't be necessary. But this is going to be 24 times 2, 48 ways with the Jill bill. Okay, part B. It is definitely springtime. And now Lee and Amy also wish to sit together. Don't worry, Tom gets his revenge in part 3. No, he doesn't kill them. Jeez. Okay. Right, we've got the Jill bill. We've got Lamey. And we've got Tom. So if we do our groups first, now there's 3 groups, which 3 factorial. Jill and Bill. The Jill bill can be Jill Bill or Bill Jill. And the Lamey can either be Lamey or Aimley. And of course, Tom is all by himself. You don't have to include him there. Poor guy. 6 times 2 times 2, 24 ways. So although you have a factorial button on your calculator, sometimes the small factorials, it's nicer just to know the values, like 3 factorial 6, 2 factorials 2, so that you can multiply that in your head quickly. Okay, Tom's Revenge, part C. Something happens, and the next time I'm surprised they even came to the park bench, but Jill and Bill are not going to sit together. Lee and Amy are on again, off again, so they can sit together or not sit together. It's not really a big issue for part C, but we just have to count the ways that Jill and Bill are not sitting together. So I've introduced this not strategy before, but this is one where the not strategy really works the best. It's hard to think about, okay, you could imagine 5 spaces and think, what are all the different ways this could happen? Well, if Jill is sitting here, then this is not Bill, and do count that way. And what happens if Jill's in the 2nd seat, and Jill's in the 3rd seat, and Jill's in the 4th seat, and deal with restrictions and count it all separately, and it could take a very long time. But if you use the not strategy is always all of them minus the bad. And in this case, counting all of them is really easy. 5 people in a row would be 5 factorial, or 120 ways. Then the bad, we already counted in part A. The bad ones where Jill and Bill were sitting together, there was 48 ways with the Jill bill. And finally, you subtract them, meaning what's left would be all the situations where Jill and Bill are not together.